Okay, so we got day 3 of the final exam review. This will be posted up, obviously, in case you need to go over something again, and so will the notes. But as usual, no homework. Your homework is just to try to practice the stuff I'm giving you. You know, make sure you know how to do it. If you have any questions, make sure you bring some the next day. But overall, this is what your test is going to look like. So we're going to do 23 to 33 today. And then we have 44 to 54, I think, and then 55, 65, something like that. So let's go ahead and get started with this one. So we're going to multiply these things. Now, multiplying fractions is pretty basic. You just multiply straight across. So you're just going to multiply this way, okay? But you can always check to see if you can reduce, if you can cancel. But if you look carefully, 2 over 5 on the first fraction, you can't reduce. 3 over 5 on the next fraction, you can't reduce. I can't cross cancel this 2 with this 5. And I can't cross cancel this 3 with this 5. So there's not much I can do here other than multiply. So this becomes 6 over 25x, and that's it. You're done. Okay? So try to reduce, try to cancel stuff out. But if you can't, then just multiply. Okay. And if you're not sure if you can reduce, you can always just get like this answer that I got, 6 over 25, put on a calculator, and it's going to still give you 6 over 25. So that's how you know it can't be reduced. If it was something that you could reduce, it'll reduce it on your calculator. Okay. So just type it in and check. Question number 24. It says solve this equation. 3 is equal to the square root of 6 minus 3b. Now notice there is a square root there. So if we got to try to get the b out of the square root, I'm going to have to get rid of the square root. And the way we do that is by squaring both sides, right? So we're going to square here. We're going to square here. Okay. So 3 squared, that's going to give me a 9. And then the square root squared cancels out. So this is just 6 minus 3b. So I'm going to move the 6 over to the left side. So let's move this 6 over there. That's by subtraction. This gives me 3 equals to negative 3b. And if you divide both sides by negative 3, you get that b is equal to negative 1. Notice I haven't really used a calculator for any of this yet. Okay, just basically squaring and solving. But I mean, not terribly difficult question. Just square both sides and you're good. Once you square it, it just becomes an algebra 1 problem, right? A 2-step problem, and you're good. Now here's the part where I would recommend, again, having a calculator so that you guys can try this. Okay, you don't have to. You can just trust me that I'm doing the right things. But right here we have properties that you're supposed to know. First off, 49y squared to the 3 halves. You're supposed to know this property. Let me put this in green here. But you're supposed to know that when you have two things multiplied together and there's a power on the outside, you can share that power to both of them. Okay, so that's what I'm going to use right here. This problem, 49y squared to the 3 halves, is going to become 49 to the 3 halves y squared to the 3 halves. Okay, at this point, I'm going to get the calculator and I'm going to type in 49 to the 3 halves power. So I'm going to put 3 over 2 as my power, hit enter. It gives me 343. But notice I haven't done anything with the letter yet, but I'm going to do that. Okay, I'm going to use the variable stuff right now. But in order to do the thing with the letter, the y squared to the 3 halves, I have to remember another property. X to the n to the m power is x to the n times m. In other words, you multiply a power with a power. So I'm going to multiply 2 times 3 halves. I'm going to go on my calculator. Let me write the letter y here. I'm going to go on my calculator and type 2 times 3 halves. Okay, and that just gives me a 3. And I'm done. 343 y to the third. Okay, so you're going to need two properties to do this problem here. Okay, when there's a product being raised to a power, you can distribute that power. But notice a product, not if it said x plus y, you don't do x to the n, y plus y to the n. That's wrong. If it's a product, two things multiplying each other to a higher power, you can distribute that power. And then once you do that, you can see my first step, that's what I did. I broke it down, 49 to the 3 halves, y squared to the 3 halves. But then when I notice a power to a power, well, a power to a power is a product, okay, n times n. So I multiplied 2 times 3 halves, that gives me a 3, and I'm done. The first part with the numbers, I can do on my calculator. Okay, 49 to the 3 halves, I got 343. I did that on my calculator. The other part, I just wrote the y, but then with the calculator, I did the multiplication. Okay, so it should be an easy problem. You just got to punch in numbers correctly and you're good. But do remember those properties, okay? Oops. This is basically the same thing, but it's saying write it in radical form. They don't want me to solve it. They want me to change it. So this is the way you're supposed to do this, okay? So the formula for this is if you have x to the p over I, that becomes the ith root of x to the p power. Okay, they want me to change it from an exponent form into a radical form. Okay, so change it from exponent form into radical form. So the 5x to the 4/5, I'm just going to write 5, I'm going to write 5x, and this is really easy. I'm going to put a radical, okay? And then my index, the I, is the denominator from the fraction, so it's going to be a 5 here, and then the 4 goes out there, and that's it. You don't have to solve anything. They just want you to rewrite it. And they're most likely going to make us do this the other way right now. They're going to give me a number like what I have in the box, and they're going to say, okay, rewrite it in exponential form. Okay? But when you're doing this, your power on the outside, the top number in the fraction goes on the outside of the parentheses. The bottom number in the fraction is your index. Okay? And this is the formula how it's supposed to look. Okay? For number 27, we're going to use the same formula. Okay, x to the p over I equals to I radical x to the p power. But this one says, here it is in radical form, write it in exponential form. So I guess if I were to write the formula again, but just backwards, they're saying, look, you have this, write it like this. That's what they want us to do. Okay? So I noticed that there's a 2x inside of the radical. So I'm going to get the 2x. I'm going to put it in a parenthesis like that. Okay? Because that's the radicand. And then I noticed the index is a 3. The power is a 5. So it's going to be 5 over 3. And that's it. That's all I have to do. I don't have to solve or simplify, nothing like that. I just have to rewrite it. Like I said before we started, this is kind of like the easier day 3. A lot of it is just conversion or using a calculator. So not a big deal. Are we okay right now? 20, I think we're 23, 24, 25. Yeah, 23, 24, 25, 26, and 27. Anybody have any questions on any of those? You want me to clear up? All right. So this one says simplify. Now, I know radical 16 is 4. But radical 8 doesn't come out to anything nice and clean. Like, I mean, I can write 2 radical 2 and that's fine. But it doesn't just become like radical 4 is, radical 8 is like 2 or anything like that. So whenever I have a problem like this, my first question is, can I combine these? So there is a property that allows you to do the following. If you have radical x over radical y, it's the same as radical x over y. Okay, you can, in your head, just think like, what if, can I divide those numbers on the inside? And I could, right? 16 divided by 8, I can divide those. So I'm going to rewrite this. square root of 16 over 8. Well, 16 over 8 is just 2. So this is just the square root of 2. And I'm done. That's it. So sometimes when you're given a fraction with radicals on top and bottom, you could think like, can I put them together and reduce them? Like, can something good happen if I do that? If I put them together and reduce them? The opposite is also true. If you were given a problem that's a square root of a fraction, okay, and you can't reduce it, and you're like, man, I wish I could only deal with the top. Well, you can. You can get a square root of a fraction and break it up into 2 square roots of a fraction. Okay, so in other words, you can go from this step here to this step here. That's allowed. You can do that. You can take a fraction and break it up into two parts. Okay, because of this property right here, it allows you to do it either way. Okay, so that's 28. 29. This is all calculator. Okay, I'm just gonna type in -3 square root of 5, and then times 2 square root of 10, and it gives me -30 square root of 2. Now, yes, there is a way to do this without the calculator, but if you have a calculator available, there's no reason why you do this the harder way. Okay, the way you're supposed to do this is you're supposed to multiply. I'll show it to you guys, but then you can say like, why do I want to do that if I can punch it in, right? But this is the way it's supposed to look. You're supposed to say, okay, that's -6 square root of 50, because you can multiply the numbers in the front, you can multiply the numbers inside the radicals. Then you say, okay, well, 50 is just 25 times 2. And the square root of 25 is what? 5. So it's -6 times 5 square root of 2, which is -30 square root of 2. That's the way it would look like if I did this using all the properties that I know. But there's no sense in doing this if you're allowed to use a calculator, which you are. So just punch it in, you're fine. Okay, it'll be quick, it'll be simple. Same with this one, okay? Let me just see, 30, 31, 32, 33, and we're done. Okay. So same with this one. Again, you can put it all together if you want to, multiply it all out, do it the long way. But this is what I would do if I was you, okay? I would get my calculator. I know I have to distribute. So I'm just going to do 2 square root of 3 and then press times square root of 8. And that gives me 4 radical 6. So it's 4 square root of 6 plus. Now I'm going to do the next part. 2 radical 3. So 2 radical 3 times radical 10. That's 2 square root of 30. Now what you're supposed to do is try to break this down as much as possible and add them, right? But let's see, I'm going to have my calculator do it for me instead of me having to work. So 4 square root of 6 plus 2 square root of 30. And it basically gives me the same answer. It just switched it. It put 2 radical 30 plus 4 radical 6, but it's the same thing. So that means nothing happens. So that's my answer. Now, if this would have given me one answer, then okay, it was able to be simplified. But it wasn't something I could simplify, so I'm just going to leave my answer the way it is. Again, important you guys know how to use your calculator so that you don't have to work too much. This is another calculator problem, right? Just simplify this. Normally what we would have done is we would have said, okay, the radical 20s go together. So 4 radical 20 minus 2 radical 20 is 2 radical 20. Let's bring that down. Let's work it all out. This is all going to simplify to something with a radical 5, okay? But the way I'm going to do it, I'm just going to punch it in. 4 radical 20 plus radical 5 minus 2 radical 20. Hit enter. It comes out to 5 radical 5. Done. I don't have to do this the long way, okay? Just work it out. Use your calculator. No big deal. We got 2 more. Any questions so far? Again, it's useful if you have a calculator. Practice this when you go home if you have your own calculators. you know, I would recommend you do that. Okay. So for this problem right here, you can do the square root of 169. That's fine. Okay. You can do that on your calculator. And that's okay. But you cannot do the square root of p to the sixth on your calculator. But I don't know if you remember, what I had you guys do when we did this was I had you guys write the index. The index here is 2. Okay. And then I told you got to make the power for the p into powers of 2, however many you can, to make them add up to 6. So we basically did this. We did square root of 169. Then we put p squared, p squared, p squared. That's p to the sixth, right? 2 plus 2 plus 2. This is 6 total powers. But now, since the index matches those powers, I can take out each individual letter. So in other words, this matches here with these, okay? So I'm going to get my calculator. Let me do the square root of 169. So the square root of 169 should be 13. Yep, this is 13. And then how many p's do I take out? P, and p, so that's p to the third, right? P to the third power. Okay? So there you go. Because you take out 3 p's, a p times a p times a p, that becomes p to the third, and you're done. Again, your calculator cannot do this letter-wise unless you have one of the more expensive ones. But it can definitely do the square root of 169. It can give you that answer, okay? It just can't give you the letter answer. So you're going to have to work that one out on your own, okay? Last one. And this one's super easy. The square root of 150, just type in square root of 150. Comes out to 5 radical 6. And we're done. That's it. That's our review for today. Okay, it was really quick. Like I said, very quick review. Most of it is you just using your calculator, punching the numbers in. Okay, so no homework for today other than kind of try to review, practice if you can.